Good morning, everyone, and a very warm welcome to all of you. I am Elvira Coper, Membership Manager here at the Australian Academy of Technological Sciences and Engineering, also known as ATSE. I'd like to begin by acknowledging the traditional owners of the lands from where I am joining from today. Myself, the Wurundjeri Woi-wurrung people, and pay my respects to their elders past and present. I would like to extend that respect to any Aboriginal or Torres Strait Islander people joining us today, as well as to acknowledge the traditional owners of whatever country you are joining us from today. As we come together to share and discuss our knowledge and experience, we also recognise the traditional knowledge and the deep history of Australia's First Peoples as the world's oldest surviving culture and Australia's first scientists and technologists. Before we get on to today's webinar, I would like to start with a little bit of housekeeping. We would like to remind all attendees that they have agreed to abide by ATSE's Code of Conduct, including as you enter your questions into the Q&A channel. This webinar will be recorded and the recording will be made available on ATSE's YouTube channel shortly after today's session. Captions are enabled today, so if you require them, they should pop up at the bottom of your screen. Be sure to submit your questions in the Q&A box at the bottom of the screen at any point throughout the webinar. Before I hand over to today's moderator and our brilliant panelists, I'd like to share a little bit about myself. I began my career in accounting many years ago, but about 12 years ago, an exciting opportunity arose for me to join ATSE as the Stellar Administration Officer. I spent around 3 rewarding years with the Stellar team before moving into the membership and awards area, where I continue to find the work both meaningful and impactful. This wonderful webinar series is brought to you by ATSE's National STEM Education Initiative, Stellar, which is designed to engage young people in rich STEM learning at school by using hands-on curriculum, aligned resources to explore the principles of sustainability and renewable energy. You can find out more by visiting stellar.org.au. The theme for today's session is Unleashing the Atom, Unlocking the World of Nuclear Science and Tech. It's an exciting chance for us to step into the powerful world of nuclear science and technology. With that, it is now my absolute pleasure to introduce you to our first speaker and ATSE Fellow, Dr. James Tickner. Dr. James Tickner has achieved global impact through his research, inventions and leadership. As co-founder and Chief Technology Officer of Chrysos Corporation, he oversaw the successful commercialization of the photon assay technology that he initially developed whilst working at CSIRO. Photon assay, sorry if I'm pronouncing that incorrectly, provides a faster, cleaner, safer and more accurate way of measuring gold, silver and other elements in mineral ores and is transforming the global mining industry. He also contributed to the invention and commercialization of numerous X-ray and nuclear-based instruments for mining and security applications, including the Eureka Prize-winning CSIRO air cargo scanner. Dr. Tickner holds more than 90 patents and has won multiple awards, including the 2022 Prime Minister's Prize for Innovation and also the ATSE Clunies Ross Technology Innovation Award. An advocate for the role of early career researchers, he helped found the Global Young Academy, an international collaboration giving young scientists a voice in policy and education. James, thank you so much for joining us today.
Thank you very much, Elvira, for the very kind introduction. And yeah, hello and welcome to everybody joining us today. It's great to have, hopefully, so many students, educators and other members of the community coming along and hopefully listening to some interesting thoughts and ideas about what you can do in nuclear science, what you can do in atomic science, and what a career in these spaces actually looks like. And I'm joining you from Ghana country in Adelaide, South Australia. Look, it's really exciting to talk about what careers look like in what I feel is a really exciting and diverse field. For me, nuclear science, it's a little bit like electricity, in the sense that everybody's familiar with sort of electricity as a power source, you know, for heating or lighting, and kind of the equivalent in nuclear science is atomic energy or nuclear weapons, some aspects of nuclear medicine where we're using radiation to change physical materials. But that's only one half of the topic or one branch of the topic. And just like we use electricity for information processing and sensing and data, we can do exactly the same things with nuclear and atomic physics. I'm going to talk about one aspect of that today. It's applications in industry. Meg, who will be joining us next, is going to talk about other applications in the life sciences and biology. But hopefully between the two of us, we can give you a sort of a real sense of some of the opportunities out there for science at the school level, science at the university level, and then what a career in this space can actually look like. So I'll talk a little bit about my sort of journey, my career. I mean, as you can probably pick up from my accent, I wasn't born in Australia. I was born in the UK. I grew up in a pretty small country town up in the Yorkshire Dales in the north of England. I was really lucky with the sort of school that I went to. I had some really dedicated and enthusiastic teachers, particularly in mathematics, particularly in chemistry, particularly in physics. Going through school, I was pretty convinced I wanted to be a mathematician. That would have been a terrible choice. I mean, I realized as I got towards the end of school, my favorite maths teacher used to start to introduce some sort of university level topics into the curriculum. And I realized that I just don't have the kind of brain for thinking that way about mathematics. I think very visually, very, in terms of physical objects. And I think that was one of the things I sort of took from this is figuring out what the way your brain works, the way you think is really important for kind of finding that early, that interest in science and that career path. Are you somebody who loves living things? Do you love the chemical world? Do you love thinking about physics? Do you love mathematics? Because all of those different ideas, different threads can kind of help shape what direction your career can kind of usefully go into. So yeah, fortunately, I stepped away from the idea of doing mathematics and went to university to do physics. I was actually the first person from my extended family to go to university, so I really had no idea what to expect, but it was just something I ended up loved doing so much. I love the learning, I love the environment, I love being with such a fantastic kind of collection of minds from all over the country and a lot of people from around the world. And I think that's where I really grew my passion in physics, and towards the end of my studies really learned to kind of love nuclear and high energy particle physics. So I actually went on from university to do a PhD. So that's sort of advanced level studies. I spent a lot of time in Germany. I worked on one of the really big atom smashers. Some of you may have heard of CERN, the big collider that's in Switzerland. Germany had its own version of that called DAISY in the city of Hamburg. And so I spent 3 years there studying what happens when you smash nuclear particles together and what comes out of those interactions. And I loved my time there. I mean, that was the kind of the basis of my PhD studies. But just towards the end, I began to feel it was all a little bit theoretical. It was a bunch of guys kind of solving problems that were so far out on the cutting edge of science that I could never see any applications. So around that time, I decided really I wanted to get more into applied science, and that's been the rest of my career journey. As I finished up my PhD, I married an Australian lady. She told me she was going back to Australia and I could tag along if I wanted to. So we ended up in Australia. I ended up working at an institution called the CSIRO. Again, I think many of you probably have heard of that. It's Australia's leading applied science agency. So I worked as part of a team that was trying to solve problems for minerals industry or security industry applications. And basically, this comes down to thinking about how we could use X-rays or nuclear radiation to see inside things. So can you see inside a rock and see whether there's any gold in there? Could you see inside a suitcase and see whether somebody's smuggling, drugs or explosives or some other materials that shouldn't be present? And so over nearly 20 years with CSIRO, we invented a bunch of different technologies, all of which we're basically using nuclear physics to solve real world problems. And for me, that was just really satisfying, going from imagining something, designing the concept, writing the equations on the whiteboard, to actually building a physical object and then seeing that instrument out in the real world and seeing people use it and get sort of practical benefits from it. And that really sort of set the bedrock for me of what I enjoyed doing, just the diversity of problems that you could solve, the number of different industries that you'd be exposed to. You'd get to learn about how mining works, about how airports work, how security works, traveling all over the world. So I mean, during the course of my career now, I've been to more than 40 different countries, meeting people, meeting scientists, meeting people using our technologists. And that was, yeah, I just found that an enormously satisfying and kind of rewarding way to spend my working life. And then about 10 years ago, I kind of took another big leap. One of the technologies that we had developed that was all about trying to measure gold, silver, and copper, so valuable metals that people were mining out of the ground. We wanted to try and get that technology more widely used. So having kind of been 20 years working for the government in a fairly safe and secure job, I came home and sort of more or less asked my wife if I could chuck that all in and start up found a new company. And that was pretty risky. I mean, most new companies fail pretty quickly, particularly in the science and technology space. And for the first couple of years, we were only 5 or 6 people trying to build this brand new technology and get it installed and get it working out in the real world. But fortunately, it really caught on. A lot of people saw the value of this process. We were replacing a pretty ugly, old-fashioned chemical process that was involved working with lead and other toxic chemicals. It was pretty polluting. It was pretty slow and sort of nasty process to actually work. So building this very sort of clean, modern X-ray based technology to solve the same problem really kind of struck a nerve with the industry. And now the company, we're 200 plus people. We're in about 12 countries around the world. And along the way, I mean, I've found that I've had to change. I mean, I'm still a scientist at heart. I still love doing my physics, but the other skills that you kind of learn about how do you manage people, how do you manage teams, how do you promote and explain what you're doing kind of come to the fore. And I think really to sort of conclude, I mean, that for me was the big learning over probably a 30-year career. Your science skills will always underpin what you do, but science is a means to an end. For me, it's the application of science that's the interesting thing. The skills that you learn as a scientist, you can use to persuade people, to talk to people, to write about what you're doing in a way that convinces people that it's interesting and it's something that they would engage with. So, something I would encourage, I think all students going through school, keep your science up, but don't forget the other skills that you build as well, because those ability to write, explain, talk, and interact with people, coupled with a scientific way of thinking, will see you go a long way. Look, I think that's enough from me. I'm very keen to hand over to Meg. She'll give you, I think, a very different perspective, both in terms of application area, but also, different career points. I feel I'm very much the old guy who's kind of summarizing a long career. Meg will give you a sort of, I think, a flavor of what it's like to be much earlier on in your career and what it's like starting out. So Meg currently works as licensing officer for ANSTO, so the operator of Australia's nuclear reactor in Sydney. So she works for ANSTO Nuclear Medicine, supporting regulatory compliance to ensure safe production of nuclear medicines. She's the recipient of the IEA Marie Skłodka-Curie Fellowship and an ATSE Elevate Leadership Scholar. Meg also serves as treasurer of the Australian Young Generation in Nuclear, or AusYGN, and she has a Bachelor in Engineering with honours from the Australian National University, and she's completing a Master of Engineering Science in Nuclear Engineering at UNSW. So Meg, over to you.
Thank you, James. My name is Meg, as James said, and I'm joining you from Darawal country in New South Wales in Sydney today. And so I guess to start with, similarly to James, in high school, I didn't set out with the intention of working in the nuclear industry. I was always really passionate and I really loved physics and maths and chemistry. But the nuclear industry kind of wasn't on my horizon. So I wanted to be a doctor, actually. And this was because when I was younger, my mum passed away from cancer. So helping people was always something I wanted to do. And initially, I thought I would do that through medicine. But I using these skills in maths and physics. I'd been interested in nuclear. I'd heard a little bit about it in physics. And then it got to year 12 and I, supported by my great high school teachers who were really, really passionate about what they did, I actually made the choice to pursue engineering. So I went to ANU. I grew up in Canberra, so I went to the Australian National University in Canberra. And this is where I started my kind of STEM journey in engineering. And I did a Bachelor of Engineering with honours, and I did a double major in biomedical science and in materials and mechanical engineering. And so during these studies, I got the opportunity. I was always really passionate. I wanted to go live overseas for a little period. And so I did a university exchange program at the University of Sheffield in the UK. And this is where I got to learn a little bit more about that nuclear science, which I'd been interested in during high school. And so I did a course and I studied nuclear materials whilst I was over there. And then so I came back to Australia and I continued my studies at the ANU. And then I got to the end of my degree. And throughout my degree, I'd pursued a lot of different opportunities. I had done an internship at the CSIRO looking at materials science. So looking at different minerals and how we can and that. And then also I did a internship with KBR, which is a contracting company that does some work in the defence industry in Australia. And I got to the end of my degree and I saw an opportunity for a graduate program at the Australian Nuclear Science and Technology Organisation, ANSTO, and I applied for it. I'd loved the bits I'd learned about nuclear throughout my undergrad and my high school studies. And so I applied for this. And although I didn't get into the graduate program, I did get another graduate engineer role at ANSTO within ANSTO Nuclear Medicine. And so as part of this role, I helped support the safe, sustainable supply of nuclear medicine to Australians. And so this was through a project engineering role. And so as part of this project engineering role, I got to learn and apply my mechanical engineering skills. But I was still really fascinated by the nuclear science and I wanted to know more. So to do this, I looked at what kind of opportunities there were to study nuclear engineering. And at that point in time, there weren't a lot, so this is about 2 years ago now. At that point in time, there weren't a lot of nuclear opportunities but to study in postgraduate studies, but the UNSW in Sydney offered a degree in nuclear engineering, a master's degree. And so I applied for the ATSE scholarship, the Elevate scholarship, to enable me and to help me study this master's in nuclear engineering, and to support me through that. And I was successful, which I'm very grateful for. And so I started studying that master's and learning more and more about nuclear science. And I decided that I wanted to move away from that kind of technical engineering role where we were doing more mechanical projects within the production facility, which produces nuclear medicine for Australians. And so just touching on nuclear medicine for a second, you might not be familiar with this. It might be a new kind of term, but nuclear medicine is used to treat and diagnose serious illnesses like cancer. And so when I was offered this opportunity at ANSTO, that was part of the reason I was so passionate to work here, was because as I mentioned, my mum passed away from cancer. So although I didn't end up going into that career in medicine, I still had the opportunity to help people and through suffering from those illnesses. And so I was working in this engineering role, and then while studying my nuclear engineering degree, I decided that I would like to move kind of into a different area. And so that's when I moved into my current role, which is as licensing officer for nuclear medicine. And so this involves making sure that when we are producing this nuclear medicine, that we're making sure that that production is safe and compliant with all of the requirements to make sure that we are keeping people safe whilst also supplying this to Australians. And throughout my work at ANSTO, I also had the opportunity, and I applied to be the treasurer for the Australian Young Generation in Nuclear. This was an opportunity outside of my work, but I saw it as an opportunity to expand my skill set. I'd never worked in as a treasurer, but it was an opportunity to connect with people. And the AusYGN, part of our goal is to support people in the nuclear industry or that may be interested in working in the nuclear industry. And so we conduct networking events. We also help with supplying people with scholarships if they'd like to attend, if there's opportunities to, for example, go overseas and attend conferences that they can learn more about the nuclear industry. So that, separate from my role at ANSTO, was another opportunity to engage with people and meet a range of people who work in this industry and learn more. And so I've been really lucky through these studies and my involvement with AusYGN to have had those opportunities to go overseas. So I mentioned that I received the ATSE scholarship, for the leadership scholarship. And in conjunction with that, I also applied for the Marie Sklodowska-Curie Fellowship, which is offered by the International Atomic Energy Agency. And so they are the global kind of organization that regulates the nuclear industry across the world. And so this was an awesome opportunity I saw as well to connect with people internationally. And so I've been really lucky. Just recently in August, I got to attend through support from the IAEA scholarship, as well as from UNSW, I got to attend the headquarters in Vienna in Austria and connect with women from all over the world who are also studying nuclear engineering. And so I'm very grateful. But this was also like a great opportunity just to connect and talk to people and hear about the different work that is available within the nuclear industry. And so I love my role, and I love this job that I have. because nuclear science helps keep people healthy, at least nuclear medicine. It supports research and drives innovation. And every day I get to work with scientists and engineers to solve complex problems. And I'm proud to be part of something that makes a real impact. And I guess to finish up, I'd really encourage you as students to follow your curiosity. You don't have to have your career figured out, but if you follow what interests you and the subjects that make you ask why, then that will lead you somewhere, and you never know what opportunities could be waiting for you. But yes, thank you.
Excellent. Look, thank you, Meg, for a great summary. We'd love to ask for questions now from the audience. I think you can post the questions into the Q&A box. I mean, look, to sort of pick up on the thread that sort of Meg was talking about at the end there, science is all about asking questions, asking why. And as I always love to say to my students, there are no dumb questions. If you feel like it's something that you don't understand, then almost certainly somebody else sitting alongside you is not understanding as well. So please throw your questions in, all and any. We'll do our best to answer those. And look, whilst we're waiting for something to come up there, I mean, Meg, I have to ask. I mean, ANSTO, I guess, operates, or I think still operates, Australia's only nuclear reactor, Opal.
Yes.
What's it really like? I think everyone has a picture of nuclear reactors with flashing lights and guys in hazmat and spacesuits and, you know, alarms going off. Is that what it's really like if you're there?
I don't work in the Opal facility, but I've been lucky enough to visit. And although it's not flashing lights and alarms and things, it is amazing. I've had the opportunity during my time at ANSTO to do a tour of the reactor and look down into the reactor pool, which is something that I feel very lucky to have been able to do. It's not everyone that can say they've looked and they've seen the reactor core, but it is surprisingly regular, surprisingly like a regular place to work. And sometimes I do have that feeling of in my job, like I'm sure everyone does. They have moments of, oh, this is boring, or I don't particularly feel like going to work today. But then I remind myself that what I do is really cool, and it's not everyone that gets to say they work at a nuclear facility, particularly in Australia, where we have just the one reactor.
Yeah. Oh, they're definitely. I've never been to Opal, but I've certainly seen a reactor overseas. And as you say, I mean, they're down in the swimming pool. It feels wrong that you can look down through the water and you're seeing into the heart of this incredibly powerful, you know, nuclear reactions that are going on. It feels that somehow water, it can't be safe, but the water keeps the radiation in, so you can stare down inside it. It's
exactly, and we have such a safe facility that we have such a safe facility that the levels of exposure that we get here are lower than what background radiation you are exposed to just in everyday life from the sun. So it's a very safe place to work.
Yeah, I guess that safety question is important because, I mean, whether it's in nuclear medicine
James,
or usage, nuclear applications always have people a little bit worried. You know, the maybe it's the perception, maybe it's what we see on TV. But I mean, do you want to talk about how sort of safety works and how, you know, the industry makes sure that what we do is completely safe?
yeah, so I guess so in terms of the nuclear industry, it's very highly regulated. So we have a regulator that ARPANSA, which is the Australian Radiation Protection Regulator, and they work in conjunction with us, and we also have international regulators like the IAEA. And we have frameworks of regulations and things and kind of rules that we have to and things that we have to follow to make sure that we're maintaining safety. And one thing that is really important is defense in depth, which means multiple layers of protection to ensure that we're doing things safely. I guess, James, one question I had for you was, so for students who might not see themselves as science people right now, but they're still interested in STEM, what would you say to keep open minds about careers in STEM?
Yeah, look, that's a great question. I think the thing about science is it leads to such a diverse range of things that you can do. I mean, I think there's probably the stereotypical image of, I'm going to say a guy, and it often is a guy in a white coat in a lab, test tubes around them, and this is the very traditional view of science. One of the things that when I was at CSIRO, they put together this fantastic video. I think it was celebrating like the 50 years or 70 years of CSIRO or something, and it was just short clips of all the scientists at CSIRO and all the things that they were doing around the world. And it was people out in the Australian outback, looking for minerals. It was astronomers looking through telescopes. It was people on ships traveling down to the Antarctic to look at, penguins and study the wildlife. It was just this breadth of careers that you could get to in science. So I think all I'd be saying is, yeah, if you kind of imagine this stereotype is that a career in science, looks like this, just the person in the lab. It's to think a lot more broadly about that. I noticed we've got a couple of questions popping up along the bottom as well. Meg, one of the questions that just popped up there, what's one of the things about your job that would surprise people that people wouldn't ordinarily expect or know?
Ooh, this is a tough one. I guess one thing that people might not know is that how common nuclear medicine is utilized by Australians. So I believe the statistic is that averaged over a lifetime, each Australian will receive about 2 nuclear medicine procedures, because these are used for all different kind of applications. So I guess that is one thing that surprises people, because you think nuclear medicine and you think it sounds really foreign and maybe even a little bit bizarre if you're not familiar, but it is really common, and it is utilized quite often, and it is something that I take great pride in being able to support and help people across Australia.
Yeah, no, I think that's a good response. Another question, and I'm going to throw this one to you, Meg, as well, because you're much closer to having been at high school than I am. If you could go back to high school and have your time again, what subject would you have paid more attention to?
I think particularly in the nuclear kind of realm, I would have paid more attention to physics. I am a self-proclaimed nerd. So in high school, I did love physics, chemistry, and maths. But I think physics was definitely the one that was kind of the closest to the nuclear science that we touched on in high school.
Yeah. I might go with a slightly unusual answer to that one. I mean, for me, it was actually, I did maths and physics and chemistry because it got me away from having to do essays, which I was not a big fan of, I have to say. Interestingly, I don't know how you find it, Meg, but when you end up in a career, actually you spend a lot of your time having to write. You have to explain things, present arguments, summarize things for people. And I kind of regretted having dropped a lot of those subjects that actually forced you into kind of writing and thinking more clearly. I don't know what your experience has been there.
Yeah, I would agree with that as well. So in high school, I liked English, but it wasn't my strongest suit. But I think, now in my role, I prepare reports regularly. I go into meetings, I present. So things like public speaking, being able to be persuasive and get a point across are really important as well. To supplement the kind of technical skills, having that opportunity and the ability to speak with people is really something that is a valuable asset, I would say.
Yeah, no, I would agree there.
James, what's been the biggest, wow, I can't believe this is my job moment?
Oh, look, there's been a few of those. I mean, look, there's certainly an opportunity as your career advances to meet some fascinating people. I met with the Prime Minister, had dinner with the Governor General, people who you'd kind of never normally imagine that you would have an opportunity to sit with or talk to. And often people like this that you see on TV, when you can actually sit down and have a chat to them, turn out to be, wonderful people, interesting and entertaining, and somehow a bit more human than you'd see on the other side of the television screen. I mean, look, the other thing for me is probably some of the places that I've been lucky enough to go to. I mean, mining happens in some pretty spectacular, some pretty remote locations all around the world. Whether you're up in the Canadian Arctic or in the we gold mining happens in jungles of Central Africa. Made a visit to the super pit in Kalgoorlie, which is one of the world's biggest gold mines, and I think the biggest hole in Australia. You stand on the rim and you watch these little trucks go down, and they look like tiny little toy trucks. And then you go down into the pit and you stand next to this truck. The wheels are 5 meters high, so that the truck is absolutely enormous. And just that sense of scale that human beings and mankind can change the planet on that kind of scale, I just still find astonishing.
Yeah, I think that's fascinating. I've also had moments like that where you realize just the scale of the universe, in terms of, and we are just one little bit of it.
Yeah.
But also how incredible science is, and how we've come so far in terms of our discoveries. In terms of so Chrysos, what is there a kind of a point you want to get to in terms of in determining like you've been successful, or how do you define success, I guess?
Oh, the unofficial company ambition is global domination, but we do say that tongue in cheek. Look, I mean, the biggest thing for us, the biggest success for us there, and where we're still kind of trying to push forward, is changing people's minds. So, I mean, it feels, it can sound that what we do is fairly niche. We're all about measuring rock to work out, is it worth mining or is it not worth mining? And the ways that people have been doing this have been around for literally biblical times. There are references in the Bible to using the sort of analytical methods that until a few years ago were absolutely standard. So for me, the success point is when we've completely convinced the industry that there are better ways of doing things, and changing hearts and minds is always a long game. I've forgotten who made the famous quote that scientific revolutions normally happen when all the people who believe the old science die off. You often don't change people's minds, but you educate a new generation. Sometimes it can feel a little bit like that. But I think for any of us who are in the kind of the applied science space, it's coming up with an idea, seeing it put into use, and then seeing it go from being this niche, novel idea to being the standard way of doing things. I mean, I look to your area, Meg. I mean, it's you don't have to go back many decades when the idea of having an X-ray for a broken bone would have been a completely outlandish thing to do, or using nuclear medicine to treat a disease, or you look at any of the modern technologies. That transition from crazy scientist idea to routine lifesaver is really interesting.
Mm. And I guess, sorry, another question, James. As someone who is more kind of advanced in their career, sometimes people think it's all smooth sailing. But have you encountered challenges, and what advice would you give to high school students in terms of like if they encounter a challenge, like what advice do you have?
Yeah, sorry, I'm laughing because chat you normally get 9 challenges per one success or something. Look, and I don't think that's unique to a career in science. I think that's kind of true in any career field. I mean, science is always about going down a lot of wrong avenues. What looks like the amazing, brilliant idea pulled out of nowhere normally comes about because you've tried 9 or 19 or 99 other ideas that didn't work first. And there needs to be a sort of certain perseverance to kind of get through those. But normally every time you go down the wrong avenue, it teaches you something. You know, it's very rare that you'll pursue an idea that just is a complete dead end. Normally you'll find a little chink, a little doorway, and that will kind of lead you to maybe an improved idea or a better idea. I mean, you've got to love that process. You know, if you're the sort of person who just wants everything to be very predefined and very clear cut, then probably a science career is not going to be the best direction for you to go. But if you're the sort of person that loves problems and, you know, that just getting that little chink of inspiration that might set you on the next step of the way, then it's a really satisfying and rewarding career to go through. I mean, I'll throw the same question back to you, Meg. I mean, what's your take on that?
Yeah, I would say similarly. One thing I always tell my friends is that if you're not winning, you're learning. And so yeah, learning to come back stronger from or see where you can pivot from. For example, when I was in my undergraduate studies, I applied for a vacation scholarship at the CSIRO, and I didn't get chosen. And that was okay. Sometimes it is, these things happen. You just learn that these things happen. But I applied the next year and I was successful. So I think it's just about, yeah, that resilience and being able to pick yourself back up and try again. I had a similar thing with my role at ANSTO. I didn't get the graduate program, but I did find another graduate role where I was able to still work here because I wanted to. And it's about directing your passion. And I think if you're doing it for the right reasons, you'll find a way.
Yes, I think there was a bit of a trend at one stage for those. Was it the CV or the biography of failure? You know, instead of having a CV that lists all the wonderful things you've achieved, you have a CV that lists all the things you tried to do and were unsuccessful at. Look, I'm conscious of time. I think we probably need to wrap up the question session now. Big thanks to Meg for joining us today, and a great thanks to everybody who's joined us in the audience. Lovely to have you here, and thank you for the people that sent questions through. We hope that everybody's learned at least one new thing today, and that this session inspires you, to consider a future in science, or maybe more specifically in nuclear science. I think that's it from myself and from Meg, and I'll hand back to Elvira to close things out.
Thank you so much, James, for your time and amazing contribution to today's session. And thank you once again, Meg. It was so inspiring to hear your career journeys, and what a great discussion for our audience. Thank you also to all of you in classrooms and offices who have joined today. We hope that you have something to take away from this session that has left you with a better idea of how many different careers you can pursue in nuclear science and tech. This was our last Shape Your Future for 2025. Thank you for joining us, and see you next time.